Okay, what's up, guys? Today I'm gonna be talking about Chapter 8, Designing Classes. So first, I'm gonna go over this PowerPoint first, and then we'll go into the big Java chapter. So we're first gonna start off with um like basically different types of like methods in a class. First, we have actors, which are basically like classes and methods that like do like change or do things to methods. They like objects do work for you. These classes basically change and like are able to like change objects and like make them useful for you. And then these are utility classes, which are basically no objects. They only have static methods, which mean that they basically these classes only like change like the private instance variables and don't really change any objects. And then these are just basically how to like well, one class would be a main method, because without a main method you can't like run any programs. And then basically it's just saying how to like name a class better. You really don't want to like just say paycheck. Like it's better to say paycheck than compute paycheck, so you don't want to like make it like verbs or actions. Okay, let's talk about cohesion. So cohesion is basically that a class should only have a single like idea behind it. It shouldn't be branching out to multiple things. So then if you do have multiple things, like separate into two classes so that you could be very cohesive. So the point is like if you're making a class like cash register, there's no point of having all these like different values and variables here. There's no point of having all these values and variables, because then you're basically making a separate idea. This is no longer just a cash register, but it's also like money denoter. Like it like calculates the value of money. So then instead of just like having both of them in one class, splitting them into two classes would make it better. So making a coin class, or it could just be a money class in general, would make it better, so that now instead of just having a set number of values and set number of like denotions for the amount of money, you can choose what type of money you want and how much the value could be. So now this not only helps you have it like more separated and make the two classes more like coherent, and they'll only have their own idea. But it's also better because now you can like have any value, any coin you want. It won't just be nickels, it won't just be dimes, it won't just be quarters. You can have any like sort of money you want. It can be like, I don't know, like euros, it could be rupees, and then you can just set the value to wherever you want. So then it won't like you won't require to add more and more of these every single time. You can just add rupees, add the value to like whatever you want, maybe convert it to dollars, whatever. And then now, when you do use your cash register your class, you can just use this coin class and you already have all the types of money you need or types of coins you want. And then next, I'm going to talk about coupling. So a class depends on another class, then it's coupling. So in this scenario, the cash register depends on coin to determine the value of the payment. So the cash register uses the coin class in order to get the money and the denotation. So without the coin class, the cash register would not be able to like get the value of whatever like type of money is getting paid. But just because cash register is depending on coin, that does not mean the coin is depending on the cash register. This is because the cash register doesn't require the the coin does not require the cash register in order to function. And then I want to talk about high coupling. High coupling is basically when many classes require other classes in order to work. This is not always a good thing, because if one class changes, that means a bunch of different classes may need to change in order to accommodate for those changes. And that might require a lot of work to change all those classes just because of one small change in a different class. So it's always better to minimize coupling just in case one class does change, so that it won't have a big impact on the other classes. And it's also better to like make sure that if you do have coupling, make sure it's not like completely like reliant on it. Like cash register is basically completely reliant on coin, and if coin ever does decide to change something, then you got to make sure that cash register doesn't completely like fail and shut down just because of coins change. And you can like see the dependencies and stuff using the unified modeling language. This basically shows which classes and objects are dependent on other classes. So one one like software that is good at showing this is BlueJ. BlueJ shows that cash register is dependent on coin in order to work, and this arrow kind of shows the dependency of each other. And this like coin doesn't have an arrow to cash register, while cash register has an arrow to coin, showing that cash register is the one that's dependent. So more about the unified modeling language. So this basically shows how like different different stuff will have different like dependencies on each other. So the line item is dependent on the product, and the product DB is also dependent on the product. This shows that if the product changes, then both the line item and the product DB has to make sure that their stuff doesn't change or get affected due to the change of product. But if line item changes or product DB changes, product won't have any effect because it's not getting depended. It's not dependent on the other two. So these are just basics of like what's in the line item, product and product DB. So this image shows high coupling because if you see here, this class, for example, right here, is reliant on this class needs this one. This class is reliant on this one, and this one. So it shows how much like reliance is going on here. So for example, if this class changes, then this class, and this class will all need to change because of the reliancy of this class. So usually you want high degree of cohesion because this shows that each class is representing its own idea, and it isn't really like kind of merging into a different like category, even though like you can make other classes for it. And low coupling is important because the less dependencies you have, the more like safe it is to make other classes because there's no like risk of getting completely changed if another class does change. So if high degree of coupling exists, then modifying one class may affect another class. And these are different. So these are different type of classes. So or different types of methods in a class. So accessor methods don't change anything, but it only like receives the data. It only like sends you the data in the methods. The mutator methods change an object inside the method. So in this case, deposit, we're changing the amount of money in your account. So you're adding an extra 1,000. But in this one, you're just checking your balance. You're not changing your balance in any way. You're just checking it. And finally, immutable classes are classes that have no mutator methods to them. For example, string. So all of these are always just like they never change any of these. These like methods never change the string itself, and they just like are kind of just accessor methods basically. Okay, now I'm going to talk about side effects. Side effects are basically any modification that is like able to be observed outside the method. So in this instance, you see the student, like while the student that size is greater than 0. So basically, while the name is greater than 0, string name student that remove I. So you're basically removing the student name. You're like removing certain parts of the name, which is not recommended, because then you're basically the side effect is you're changing the person's name, which is not like you don't want to change a person's name without like that would be weird. I don't know. Like you don't want to change a person's name. So that would be a side effect to this method because if you do carry out this method, the name of the student would be kind of changed. And then so side effects aren't always like a bad thing. It could be a good thing, but usually like side effects are just a change in any sort, not like always good or not always bad. See, look, oh, it removes all the names. Oh, well, it doesn't really change it, but it removes it, which is also not good. Okay, now, well, preconditions are probably one of the biggest things to talk about because preconditions are sometimes like the most confusing part of Java docking. So for Java docking, preconditions are basically a requirement that the user, the user of the method must meet in order to like make sure that the method performs its task. So preconditions basically establish like something you must do before you call this method in order to make sure the method works at its intended purpose. So people usually use preconditions to restrict the parameter. So Here we're restricting the parameter to make sure the parameter is greater than equal to 0. So it's basically saying you can't have it be negative, or else the method won't work to its intended purpose, which is why it's restricting it to be 0 or greater. Or it's required that a method is only called when the object is at an appropriate state. So this is basically kind of the same thing, but instead of it being like a parameter, but it's an object. So instead of like the parameter being in a specific, like for this int being a specific value, this object has to be in a specific state in order for this method to be worked properly. And then if the precondition is violated, the like method is not responsible for being like correct. So it's kind of like almost of it's like a contract almost. So like if the precondition is met, the method will be right. So that's like kind of like a guarantee almost from the user. It's basically saying if you do this, then it's guaranteed to like be successful. So it's like a contract. But if the user fails to put their side of the contract, then the method's not like responsible for being accurate. So if user doesn't require or doesn't meet the preconditions, then the method is not required to like do its job. So then usually methods like throw an exception if the precondition is like violated. We don't really go into exceptions yet, so I'm just gonna skip past this. And then sometimes like even if they like don't fulfill the precondition, you don't have to like check for it. It may just take a lot of time, and it's like kind of also their fault, like that they didn't meet the precondition. The only bad thing about it is that now like your data isn't going to be good. So it's basically they're going to be like putting in an input that's not wrong, and they'll be getting even worse data back. So it's usually not a win-win for both sides. And then sometimes like we did for the the slope lab we did today, we checked to see that the x2 and x are the same, and we used the if statement to make sure that even if the precondition is not met, it doesn't like harm any of the data. It just doesn't continue on. So this if statement is usually just there to make sure that even if the precondition is not met, it doesn't like give bad data. Now postconditions. Postconditions are basically what the method is promising to do. So this is like the method's side of the contract. If the like user fulfills their part of the contract and their precondition, then the method is now like responsible for like fulfilling its part of the contract and its postcondition. So this postcondition is basically a guarantee saying that if you do the precondition, it will do the proper like execution of this method. So then it must like it's kind of like basically, I don't know what to say. It's basically this a guarantee. I don't know. I guess it is. And then so there's two types of post conditions. So usually one of them is to just say like, for example, here we have one of our like labs we had was the geometry lab, right? And then in the geometry lab we have like a post condition that like a precondition that if the radius is greater than equal to 0, then the volume of the sphere will be greater than equal to 0. So this is a post condition saying like the get method will like return what it's intended to do, as shown here. The return value is computed correctly. So basically, when the radius is greater than 0, the returning of the volume will also be greater than 0. And then the object is in a certain state after the method is completed. So in our like college student lab, if we go to our post condition for this one here, the object will be in the correct like location. So we're not like saying that it'll be something, but it's different from the first one because the first one's like saying that it will return a certain value, but this one's saying that the like private instance variable measure will be in a certain this variable measure will be in a certain condition almost. We're saying we're setting the major to something new, and as long as this is a real major, the get major will return a real major. So it's kind of different. Okay, yeah, like as I was saying, it's basically a contract. So if the caller fulfills their preconditions, then the method must fulfill its post conditions. So basically, um, the post condition shouldn't be the same thing as a return statement. So it shouldn't be like post condition return method will return this. So it's basically not supposed to be a repetition, but it's supposed to be something different about the precondition. So in our case, for like the geometry lab, in for example, we're not specifically saying that like it will return volume. We're not saying precondition radius is greater than 0, post condition at return volume. I should be having a return volume here. I missed it, but the post condition should be saying like get sphere is greater than 0, saying like the method itself will give this, but it should never be saying the it will return volume. So it should never be saying return like volume, because the way like post precondition and post conditions work is based on the interface. So when the user sees the precondition and post condition, they don't get to see all this code inside your method. They only get to see like this part of the method. So they won't be able to see what the word volume is. They won't see this variable volume because that's all in your side of the code. That's all the back end. It's all like the private stuff. The user of your method will only be able to see the interface of your method, which would just be the public static double this part. So there's no like reason to be using the word volume, because the user won't know what volume is in this scenario, because they won't be able to see double volume equals like the formula for volume. So then we would have to use get sphere volume as greater than equal to 0, not only because it won't be a repetition of the return statement, but also because you're not able to use anything except anything that's in the interface itself. So you won't be able to use any of this like variables R3 like well, you'll be able to use radius because it's part of the interface, but you won't be able to use R3 and volume because the user won't be able to see part of this back end stuff. Okay, yes, here it is. Formulate pre and post conditions only in the term of the interface of the class. So we're supposed to use like here we're supposed to like instead of saying balance, you're supposed to say get balance, because the user won't be able to see like the variable balance. This is basically what I was talking about in geometry. You're supposed to use the method name or the parameter, because that's the only things the user of your method could see. They won't be able to see any of this, like any of the variables you use, such as balance. So then they'll have no clue what this means, but they'll be able to understand what this means because that's something they'll be able to see in the interface. Okay, now we'll talk about static. Well, we've done static methods before. Uh, I'll go over it, but I'll go pretty quickly over it because it's not really like too much. We've used static methods before, so it's not like something crazy. So basically, a static method is basically something that is called straight from the class itself, almost. It belongs to the class and not an object, so it goes straight from the class itself. So a static method is not like involving an object, so it does not have an implicit parameter. That's why we say like like we don't ever say like x square root. We use math dot square root because we're using the class name. We're not using any object to call it. Okay. So one reason we use static methods is because if a method manipulates a class that you don't own, you can't like add to this class. So basically, you can't really like use an object because it's not a class you own. So like static method, you'll still be able to use it, but you're not able to change any of the objects. So um, for this example, like public static double area rectangle rect return rect dot get width times get height, like we don't really need like an object to go off this, because all you need is basically just the rectangle itself. You don't need any object to go off this, because essentially you're just trying to find the like area of this. You're trying to find the area of this rectangle, so you don't need an implicit parameter here. All you need is the dimensions of the rectangle with the parameter rectangle rect. Another reason is when you do not have a constructor, because when you have a constructor, you'll have all like the parameters and the initialized like fields that you can use in your class as objects. But when you don't have a constructor, you can just use a static. You can just use static methods so that you don't need to like rely on any objects or private instance fields. Okay, so usually you should not be using like a bunch of static methods because that's really not like for object oriented programming because we're not really using objects here. We're only going directly based on the class. So usually for this class, it's better to use like normal methods because then you'll actually be using based off an object and you'll be changing or like accessing a certain object and not just like the entirety of the class. Okay, static variables. So the static variable belongs to the entire class, not any object of the class. So for the bank account, it's basically the private static int last number. So it's basically it's not each person gets their own last assigned number, but this static is for like the entirety of the entire class. Okay, the entirety, nice. But it's basically for the entire class, so that like each time a certain like constructor is made, it's not like for a specific person, but it's like indiv. It is for a specific person. It's not for the like. Okay. So the use of this private static int last number is basically due to the fact that like we want it for each person to have their own number, but we don't want it to be like repeated number. We want each person to have a number increased by one. So instead of having each person have 1,000, we're gonna have it set to the entire class, so no one person can own the last assigned number. So if it wasn't static, each person would have like each person would be able to have this, so then everybody would own like this for themselves. But we want it to be owned by the class itself, so then it would be used for everybody, but no one would own it. Like no one would separately own it. Okay, so before we go into this, I wanna like show you the example we did for the student class. So we used the what is it? Yeah, private static int, the unique ID. So that's what the U stands for, the unique ID. So this basically says like each person will have an ID that starts from 21000 or 2100. No, not 21,000. So then each person will have their ID here. You see, each person will have their own ID, but the number of the ID will be unique to every single person. Not everyone will have the same one. So how this works is that first we add 1 to each the ID, so that every single time a constructor is created, the UID will be increased by 1, so that every person's ID will be completely different. It won't be the same one over and over again. So every single time a constructor is made, that means a new student is being created. A new student profile is being created. So with this new student profile, the UID will be increased by 1. So that makes it so that every student and every student profile will have their own ID, and it won't be repeated. It won't be shared with anyone else. Okay, so this is basically the same thing as what we see in the code. We're increasing the last number assigned so that each person can have their own last number. So no one will have their own bank, like their own won't share a bank account with anyone else. Okay, so there's two ways to initialize it. So usually you can either initialize it outside the so either you just like initialize it without any like set value. You could just say private static int last number assigned. There's no value to it, so then it just basically 0 for numbers. Like it has a default. It has a default for everything. So it has the default for an int or double is 0. For boolean, it's a false, and for objects, it's null. So it has its own like distinct default variable. So in this case it's an integer, right? So private static int last number assigned. Last number assigned will automatically start out as 0 because that's its like default. Or you can start it off with a certain value. This private static int last number assigned already starts off as 1,000 in this class, so it's no longer just 0, but it's 1,000. So static variables should always be declared as private, because if it's public, that means everybody has access to it. But we want it to be like it's only owned by the class, right? We don't want it to be like used by everybody. We want it to be only used by the class only one time. We don't want it, like everybody to be able to have it. Okay, now I think we already talked about scope of variables before, but yeah, I'll go over this quickly. So basically, scope of a variable is how much, like, how do I explain this? But okay, region of program code in which it's legal to use to reference as an identifier. So it's basically saying, like, how much of the code are you able, like, what parts of the code are you able to use this certain variable? Like, yeah, basically, what parts of the code are you able to use this variable? So in this case, a local variable, you'd only be able to use it in this method. This variable, double R, would only be able to be used in this method. So that's a local variable because it's only in this one method. So it's kind of like if you think about it, this is like a house. This is like kind of like a house almost, and then like you keep on expanding to like a town and then like a city. So then in your house, like you'll only be able to use it this only in your house type. I don't know if that's the right analogy. Um, if that doesn't make sense, completely ignore it. But if it makes sense, good, I guess. But so how I think, how like it's how I think about it, but it's kind of weird. So basically, like this double R is like a house. It's very small, and it's only like you can only use it inside the house. Like only able to be used inside this like method or this house, right? Same with this rectangle R. This rectangle house is only be able to use in this house. It's a separate house, so you won't be able to use this in the first house, but you'll only be able to use it in the second house. It's by specific houses, right? You'll only be able to use it in that specific house. And then as we like oh wait, this is still local. Scopes of local variables cannot contain the definition of another one in the same one. So we see here we first see the variable r made as a rectangle. So now you can't have the variable r used in this if statement, because you can't have two r's in the same house. Like you can't have two r's in the same house, or else it's basically like they're conflicting. They're like, I don't know which one is which. It's gonna be confusing. However, this is kind of different if they don't like this R is used only in this if statement. So it's like it's tiny room almost. Think about it like a room. Like this R is for this specific room and this R is for this specific room. Each one is like kind of like closed off in its brackets almost, like it's like each room in this brackets the room, and then in this brackets the separate room almost. And then if you think about it, like the private variables here you see are like an entire like almost like an entire city. It can be anywhere in the entire city. It can be used in any one of those homes in those cities, right? As opposed to like this double value here, which can only be used in this house. This private double can be used in an entire city, right? It can be used in any single house, any single like town in the city. As long as it coincides in the city, it can be used anywhere, right? So that's like the scope, like almost like a map, where like it goes from like a little neighborhood to like a big city to like the state. So now this one can be seen like you can use this anywhere in the entire state or anywhere in the like overlapping everything in the region, while this one can only be used in like a certain house. I don't know. I like to use that. analogy. I don't know if that really works, but basically, now like you see these two are different, like because they're getting like reinserted again. These two are different variables, and if it's a local variable, the local variable takes precedence over the like more broad variable. So the variable, the house variable, this one is only in the house. It takes precedence over the variable that's like over the entire city. So if you do like double value equals value or like equals 1, then this value won't change, but this value will change because the value inside the more local variable will take precedence over the more broad variable. So then, oh wait. So then, if you want to use this private instance variable, then you'd have to use this dot value to indicate that you're talking about like this one and not just a local one. But that's what it means when a local variable can shadow a variable with the same name. So the one that's more local takes precedence over the one that's more broad. Questions? Hmm, yeah. That's the what is it? That's the PowerPoint. Yeah, the PowerPoint. Okay. I'll do. Okay. I'll see how much this one is, and if you want, I'll make another video over the big Java. But first, check this, and if you still have questions and stuff, like leave comments below, and I'll make a video on your questions using the big Java as well.